In this fast-paced society, how often have you stopped to appreciate the beauty of the things around you? Have you ever paused and pondered about the underlying principles that govern the universe? How about contemplating about the processes and mechanisms that make our lives easier, if not more comfortable? Most people do the same routine or task every day, and the fundamental concepts that make these activities possible are often overlooked. As rational creatures, we tend to identify and follow patterns whether consciously or subconsciously. So, in this chapter, we will need to identify where can we see mathematics. Or the title of the first lesson, Mathematics in Our World. As Ian Stewart said, we live in a universe of patterns. This is true. As rational creatures, we tend to identify and follow patterns, whether consciously or subconsciously. Recognizing these patterns feel natural, like our brain is hardwired to recognize them. Early humans recognized this repeating interval of the day and night, the cycle of the moon, the rising and falling of tides, the changing of seasons. Awareness of these patterns allowed humans to survive. In a similar fashion, many flora and fauna also follow certain patterns, such as the arrangement of leaves and stems in a plant, the shape of a snowflake, the flower petals, or even the shape of a snail's shell. Do you also notice patterns around you? What other examples can you think of? So in this chapter, we will be looking at patterns and regularities in the world and how mathematics come into play both in nature and in human endeavors. So these are the intended learning outcomes for this chapter. First, identify the patterns in nature and regularities in the world. Second, articulate the importance of mathematics in one's life. Third, argue about nature of mathematics, what it is, how it is expressed, represented, and used. And lastly, express appreciation for mathematics as a human endeavor. So for the first lesson in this chapter, we will be discovering about the different patterns and numbers in nature and the world. So here are the patterns. First, the patterns we see in the butterfly, we call it a symmetry. The spirals of the shell, the curves, bends, or loops of the rivers, or we call it as meanders, the waves, foams or bubbles, tessellations, cracks or fractures, stripes and spots, fractals, and different affine transformations. These are the patterns and numbers in nature and the world. Patterns can also be sequential, spatial, temporal, and even linguistic. The most basic pattern is the sequence of dates in the calendar, such as 1, 2, 3, and so on. These are the dates we use month after month. Then we have the 7 days in a week, like Sunday, Monday, Tuesday, and so on. Then we also have the 12 months in a year, like January, February, March, April, and so on. All these phenomena create a repetition of names or events called regularity. So in this presentation, we will talk about the different patterns we see in the world and in nature. So to start, let's have the symmetry. So this is an example of symmetry, the fern. Okay? And we also have the butterfly. So what is symmetry? Symmetry comes from a Greek word meaning to measure together and is widely used in the study of geometry. It means that one shape becomes exactly like another when you move it in some way, either you flip, turn, or slide. For two objects to be symmetrical, they must be the same size and shape, with one object having a different orientation from the first, just like this butterfly. So the left is the mirror image of the right wing. So the body of the butterfly here, we call it as the axis of symmetry. So this is an example of reflection symmetry. But not all objects have symmetry. If an object is not symmetrical, it is called asymmetric. So there are three types of symmetries. The first one is reflection symmetry. It is also known as bilateral symmetry. It is the mirror effect, or when one object is reflected or flipped across an axis or a plane to create an image of itself. So in nature, we can see the face of the fly. We can also apply reflection symmetry in garments, like for example, a bomber jacket with colorful denim, or the ethnic style, Philippines. We call this as batik. We can also apply reflection symmetry in building architectural structures, like the Taj Mahal, or even in movement of animals, the way we walk, okay, or move. So another type of symmetry is the radial symmetry. It is also known as rotation symmetry. It is when one object is rotated or turned in a certain direction or degree around a point. So where can we see radial symmetry? We can see it in the arrangement of petals of the flowers. We can also apply radial symmetry in gears or even the wheels of the bicycle. Radial symmetry is also observed in the formation of snowflakes. So observe that this part is moved or rotated in 360-degree angle. So that is an example of, these are examples of radial symmetries. So the third type of symmetry is the translation symmetry. It is when something has undergone a movement, a shift, or a slide in a specified distance without any rotation, reflection, or change of an image. So for example, we have the beehive. So as you can see, this shape is translated to the right or even to the left or even diagonally. So the hexagon was not rotated nor reflected. It was just moved or shifted. We can also see translation symmetry in the floor bricks or even in the skin of the pineapple. So the next pattern we see in nature are the spirals. So these are examples of spiral patterns we see in nature. A spiral is a curve which emanates from a point, moving farther away as it revolves around a point. For example, in the shell, so this is the point of origin. Then the point needs to move farther away around the point with a specific distance and degree. Then you create a spiral. So in the natural world, we find spirals in the DNA double helix, sunflowers, the path of draining water, galaxies, horns of the various animals, mollusk shells, the nautilus shell, snail shells, and whirlpools, ferns, and algae. So this is a picture of the double helix of our DNA, the spiral shells of a sea creature, or even the arrangement of thorns that we see from the top view of the cactus. We can also see spiral patterns when we cut the cabbage into half, or even in the pine cones, and in many other natural phenomena. So the golden spiral appears in the many dimensions, not in the human, or crystal, or celestial, but in the aqua worlds, in all forms and bizarre proportions. The spiral is the carrier of information. It builds our homes, our bodies, and consciousness, according to Jane 108. So another type of pattern we see in nature are the meanders. So this is an example of meanders. So what is a meander? So the term meander is one which refers to a winding curve or bend in a river. Meanders are typically landforms at the middle and lower courses of a river, just like this example. Meander gradients are usually more gentle and they experience lateral sideways erosions which widen the channel of the river at the middle and the lower courses of a river. So these are the bends, the curves, and the loops of the river. So another pattern we see in nature are the waves or dunes. So this is an example of sand dunes. So we produce a wave in the water if we create a disturbance. So a wave is a physical phenomenon characterized by its frequency, wavelength, and amplitude. In general, waves transfer energy from one location to another, in which case they have a velocity. Take note, waves are produced when there is disturbance that transfers energy through matter or space. So the waves that are common are sound waves, electromagnetic waves, and light waves. So the next pattern we see in nature are the bubbles and foams. For example, the sea foams and the beer foams and bubbles. So a foam is a substance made by trapping air or gas bubbles inside a solid or liquid. Examples of foams formed by gases and liquids include sea foams, fire retardant foam, and soap bubbles. Rising bread dough may be considered a semi-solid foam. Solid foams include dry wood, polystyrene foam, memory foam, and matte foam, as for camping and yoga mats. Another pattern we see in nature is the tessellation. So the beehive is also considered an example of tessellation. So what is a tessellation? A tessellation is tiling that uses shapes to cover a surface with no gaps or overlaps. So for example, a picture of the kitchen floor with tiles, and you are looking at the tessellation, so that the floor tiles are considered as example of tessellation. And in nature, we can see it in beehive. Hexagon covers the surface with no gaps or overlaps. So that is, the pattern is repeated without leaving any gaps or overlaps. Another is the skin of the pineapple. So this pattern covers the pineapple with it without gaps or overlaps. The bricks of the floor, or we can also see a tessellation in art. So as you can see, the creator of this art used the pattern of butterfly. Then he tessellated it without gaps or overlaps. So this is an example of a tessellation. Also, we can see tessellations in objects or even in living things. So what is this? So this is a dodecahedron expressed as a living organism. Technically, it is a coastal phytoplanktonic algae, and its fossil record dates back to 100 million years ago. It is so small, its diameter would be a few microns. So there are living organism follows the rules of mathematics or geometry. Another pattern we see in nature are the fractures and cracks. So the fracture occurs when the applied stress is sufficient to break the atomic bonds of the solid, or it is considered as the separation of an object into two or more pieces under stress. But a crack is just a line on a surface of something along which it has split with breaking into separate parts. So a crack is just a smaller version of the fracture. Okay, so ang fracture, it is a complete separation. So example, we have here the fractures, stone fractures, and we have here the cracks in the branches of the wood or in the land. Another pattern that we see in nature are the spots and stripes. So stripes of the zebra, stripes of the cat, spots of the Dalmatian, or spots of some fishes. Some plants do have stripes. Some plants also have spots. So stripes are made by series of bands or strips, often of the same width and color along the length. The pattern we see in nature is what we call as the fractal. So a fractal is a never-ending pattern. It might seem so chaotic, unarranged, but it is still considered as pattern. So these are examples of fractal patterns. We have the ferns and the parts of the broccoli. So to define, a fractal is a never-ending pattern. Fractals are infinitely complex patterns that are self-similar across different scales. They are created by repeating a simple process over and over in an ongoing feedback loop. For example, trees, rivers, broccoli, cauliflower, blood vessels, and snowflakes. So this is an example of fractal. So for example, we have the flower. This whole flower is just similar to its smaller part, and one part of it is just similar to its smaller part. So that is an example of fractals. Never-ending self-similarity. Another example is the cauliflower. The cauliflower, when you see it as a whole, you can see it to its smaller part here. Yeah. And from each part, we can see it to its smaller part again. That's why the cauliflower is considered as the fractal. Another one, this triangle. So this is Kaspersky triangle. So this triangle can be seen in the centermost of the blue triangle. So if we divide it here, we can also see it another triangle here. Then we see another triangle. Then we see another triangle. So it exhibited self-similarity. Another one, in the central processing unit or even in the motherboard, we see there a chip. So we see in this picture, we can see that there is a big square, then surrounded by 9 smaller squares. Then each square is again surrounded by 9 smaller squares. Then each square is again surrounded by 1, 2, 3, 4, 5, 6, 7, 8 squares, and so on. These are also other examples of fractals. Our nerves, the branches of the tree, and many other things. And the last pattern we see in nature is what we call as the affine transformations. So affine transformation is a linear mapping method that preserves points, straight lines, and planes. The processes involved in affine transformations are rotation, reflection, and scaling. Examples are broccolis and cauliflowers. So as you can see, this part is just repeated. Okay. So for example, this part is rotated around this broccoli. Then it is repeated na siya self-similarity and copied itself into smaller scales. So this is an example of affine transformation. So it applies rotation because you can see it when you rotate the broccoli. You can also see scaling. So there is a smaller scale and larger scale. So to summarize, these are the patterns and numbers that we see in nature and the world. So first, we have the symmetry, spirals, meanders, waves, foams, tessellation, cracks or fracture, the stripes and spots, the fractals, and the affine transformations. So our synthesis for this presentation, we can say that nature's patterns are not just there to be admired. They are vital clues to the rules that govern natural processes, and by using mathematics, the great secret of nature and the universe have been discovered. Mathematics definitely is a useful way to think about nature, to understand how they happen, to understand why they happen, to organize the underlying patterns and regularities in the most satisfying way, to predict how nature will behave, to control nature for our own ends, and to make practical use of what we have learned about the world. So as Galileo Galilei said, the book of nature is written in the language of mathematics. So this has been Jennifer B. Carillo, and thank you for watching.